So today's lesson is dealing with similar figures. Similar figures have, and the definition you should be writing down, have the same shape but not necessarily same size. Different examples that we see similar figures are in obviously photography, uses maybe in architecture, and different things like that. Usually we describe similar figures by a scale factor, so we usually know that figures are similar because they have the same scale factor with each corresponding side. How do we work out the scale factor? And this is a bit of a recap from what we've done previously, but you should know the formula by now, and it's the image length or the new length over the original length. Here's an example of a shape, and you would measure GD and measure MH, and you would find the length of MH and divide it by GD, and you do that for every corresponding side, and you shall get a scale factor. Sometimes scale factors are also reduced, so we still call it sometimes an enlargement, but things can also be reduced, so keep that in mind. So just don't think that you're only going to get a whole number. You might get a fraction or a decimal. When we're finding the scale factor of similar shapes, and make sure you copy this down if you need to pause and do so. In example 1, we've got a shape which has sides already given to you, the lengths and measurement. You then have to work out the scale factor and see if the scale factor is the same for each corresponding side. You could use 18 over 12 or 30 over 20, whichever one you choose, but just make sure that the scale factor is the same for both, whichever order you do. Punch that into your calculator, or you can just do it by mental math. So you should know it's 1 1/2, and the same for that one. So therefore, you can work out the scale factor by just putting it into this formula, the new over the OG, or the new over the old. When we're working out an example, there's two different ways of dealing with scale factor. One is actually constructing or reconstructing a shape given a scale factor. So I'm going to show you how to do that. And we're going to increase this by a scale factor of 2. So first point is to count how many squares across in the original shape. And be it this time it's only a scale factor of 2, we know to multiply those two boxes across by 2. So 2 squares across, and so the new shape, it will be 4. So you've got your gridded paper, and you draw a line 4 across. You do that for every side on the shape, and so that's another 2, which would be 4, and so on and so on. And you then therefore get a brand new shape. Obviously yours will be a lot more accurate because my grid has been, it's a bit skewed, but as long as your numbers are correct, and you can double check, do a visual check that that's 2, so it should be 4 all the way around. So therefore I have a new shape with a scale factor of 2. Testing whether each pair of figures are similar or not, and so this is now going into example 3. The way we go about doing that is to make sure, and obviously the similarity symbol is 3 lines going up and down, which you should know, but what we need to do is now we actually are not given the lengths measured. So we've got to take our ruler out and measure accurately, just like we did scale drawings, and we match the corresponding sides accurately. So GH over the CD, GH over CD, that's the corresponding side. Measured, it's 38 over 19, which then, remember, we always need to reduce a fraction to its lowest common denominator, and this is 2, so its lowest common is 2. Just punching that into your calculator gives you that answer. And we do that again for another corresponding side, and again it's 2. So just as a double check, we need to make sure that both of the scale factors are 2, because if they're not, then they're not similar. So you need to make sure, obviously this is a rectangle, so you don't need to do every single side, but if it was a different shape, you would have to do every single side if it was an irregular shape. And If it's not 2 and not 2 there, then you know that the shape is not similar. And we have to write our therefore statement, which is saying, therefore, we just prove GH over CD is equal to HK over DE. Therefore, this shape is similar, using the symbol that similarity is similar to that shape, GHKL. Moving on, we now have two shapes. And I just rotated this shape so it's, in the same rotation as this shape to be able to prove that these are similar. So first of all, the example is saying list all the pairs of matching sides and matching angles, because obviously that's how we prove if the shapes are similar. So again, I just rotated the shape and redrew it out. You would do this in your book using your ruler and being very precise. Wrong is that you transpose these letters because of the rotation of the shape. You can make the mistake of putting the T there or the R there or the P there rather than what the Q is. So just make sure if you rotate the shape and need to rewrite it, some of us visually can just see it, but some of us actually have to redraw it. So just make sure when you do rotate it that the allocated corner letters are accurate. So that's where you can make the mistake. So we're going to list all the pairs of matching sides and matching angles, and we need to use the correct notation to write similarity statements relating these two quadrilaterals. So we're proving that the matching pair of sides are, and we can see that, like I said, from the rotation of it very simply, Kn is the matching side is QR, and so forth and so forth and so forth. The matching angles, again, and this is after rotating it, you can quickly see that the angle K is and angle R are the matching angles. And so we then can write our similarity statement, which is saying angle K matches with angle R, and so forth and so forth and so forth. And we write always our therefore statement, so we can therefore state that KLMN is similar to RTPQ. So that's pretty much it for today's lesson. Make sure that you pause and re-listen, and make sure that you fill out your performa sheet that's being handed out to you regarding the flip lesson. So enjoy it, revisit it, and we'll come back tomorrow to do some more examples.